So in this problem, we need to verify the fact that if the coordinates of a triangle have integral coordinates, then the triangle cannot be an equilateral triangle. So let's say we have a triangle ABC. Then we are going to suppose that the coordinates of A, let it be x1 and y1. So here both x1 and y1 are integers. For B, the coordinate, let it be x2, y2. And coordinates for C, let it be x3, y3. So these are the coordinates of the triangle ABC. So we are choosing the coordinates such that xi and yi, where I can take the value 1, 2 and 3 are all integers. These are integers value that we are choosing. Now, if we know the coordinates of the vertices of a triangle, then we can also find out its area. So let's define the formula for finding out the area of a triangle when the coordinates of its vertices are known. So if the three vertices of a triangle have the coordinates given by x1, y1, x2, y2 and x3, y3, then the area of the triangle is given by this formula. We have half times the absolute value of x1 multiplied to y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Now, since we have considered the fact that xi, yi, these are all integers value, then this entire expression is going to be an integer. And since we're dividing by 2, so this area of the triangle is going to be a rational number. Fine. So this is a condition that if the coordinates are integer, then the area of the triangle must give us a rational value. Let's suppose this triangle ABC is equilateral. Now, if it's an equilateral triangle, let's write it down, if ABC is an equilateral triangle, then the area of the triangle, so an area of the triangle ABC, that's going to be given by the formula. We have square root of 3 over 4 multiplied to side square. So that is how we can find out the area of any equilateral triangle. Now clearly side A, since it's an equilateral triangle, AB will be equals to BC and BC equals to CA. Now we can find out the length of any of the sides by using the distance formula. So let me note down the length of AB. So AB will be equals to, we'll take the square root. Underneath the square root, first we'll have to take the difference of the x coordinate. So that's going to be x2 minus x1. We square it and then add it to the square of the difference of the y coordinate. So that's going to be y2 minus y1. Now since we have already chosen x2, x1, y2, y1 as integers value, this is going to give us a square root of an integer value. Now also we are taking the square of that particular side. So taking the square of that particular side, so that means AB squared, that's going to give us an integer value. However, here we have a factor square root of 3 over 4. Square root of 3 means it's an irrational number, which means that we have an irrational number coming out as the area of the equilateral triangle ABC. But we say that if we choose the coordinates as integer values, then the area is always going to be a rational number, whereas for an equilateral triangle, the area always comes out to be an irrational number. So that would mean that if the coordinates of the vertices of a triangle are integer value, then that triangle can never be an equilateral triangle, hence proved.